Welcome to Python Pro, a 30-day workshop by CTC. And today we'll be moving on to, say, the switch cases. So, in Python, like almost all of us think Python lacks switch cases, but it is not the same in real case. You have a lot of varieties in achieving the same switch case here as well. So, switch case in Python is a selection control statement. Say if you're going to ask what is it going to do, a switch case expression is evaluated once, and the value of the expression is compared with the value of each case. And if there is a match, that block is going to be executed. And if not, say it searches for the other cases for the match, else it goes and executes the default case. So in Python, we don't have an inbuilt, say, switch case statements, but after Python 3.10, we have the match and case keywords that help us bring up the same switch case that we have in other, say, languages. Say, why do we need to use switch case? Say you have more number of options and more number of comparisons to be done, and each comparison takes, say, a particular unique code block, and instead of having it in a messed up structure, you can have it in a better, neatly readable and more maintainable manner in switch cases. So moving on to the syntax, we have the first syntax that we are going to look at for switch cases is that the match and case keywords, using the match and case keywords. So the match keyword is going to evaluate our value, and the case is what it is going to compare it with. So the variable or the expression goes after the match, and then you have the case where you put your pattern 1, 2, and then your default case is represented by the underscore, and you put the action as default, so which means not even a single pattern matched over here. So this is very similar to an if else or if, elif, and else. So the other patterns that you can see for implementing the switch case is going to be the if else, and then you have the dictionary mapping, and you have something called classes. So we'll look at the other ways also. So now that you understand how you can use this match and case, let us move on to see how other ways can be implemented. So the if, elif, and else, very similar to the match and case. Say the comparison is explicit here, whereas the comparison is implicit there. So you just compare, and if this is not matching, you go to another, then other, and then if nothing matches, you put an else outside and you say none of the statements were matched. So this is one of the easy way. But if you're asking why you use switch case rather than else if or if else, all of those, it is just for more readable and maintainable purpose. See, using these two methods may be comparable, and we might not have much of a difference with if else and the switch case. But moving on to the dictionary matching and classes, we have a better upper hand over there also. So now if you're more familiar with the dictionary, the way of storing key value pairs, you can relate more with how this can be converted into a switch case pattern. Say here we have a dictionary called switcher, and our keys are going to be numbers from 1 to 7, and the values are going to be the days of the week. So here the case is from the match case, say example, or the syntax that we had, the match case syntax, the case will be replaced by the keys in dictionary, whereas the match statement is now going to be replaced by the get function. So this get function is going to help you retrieve a particular value of a key in a dictionary. And over here, say the values here are made up into different functions where you have, say this example looks simple. You're just going to return the day of week. But say if your code is more complex, your each function is going to do some small parts of job, and it is going to return a value or some modified entity. So dictionary mapping is yet another efficient way to handle multiple option scenario. Say you have, instead of using the else if or the match case, dictionary mapping is more useful in case of complex code scenarios. So here for the explanation part, so switcher is a dictionary that is going to contain our key and the values that we'll be needing to execute, where the values hold the name of each function. Say we have a Monday function, Tuesday, Wednesday, and so on. So these names are being passed on to the values in the dictionary. And the switch day of week function, say it takes day of week as a parameter and it executes the corresponding function from the dictionary. So when this matches, say take this print statement where I'm going to give switch of 3, so it moves on to this function switch and day of week is given as 3. So now it replaces this day of week as 3, and then default is when your key is not found. So I'm just passing my key over here, and get function basically does take the input as key and it returns the corresponding value to that key. So my key over here is going to be 3, and 3 is there, so I need not go into the default case. So now the value for this key is going to be Wednesday. So this part will return Wednesday, and in the end I have the parentheses which represent a function. So this is going to move to the Wednesday function where I have written Wednesday. So that will be my output. Moving on to the classes, using classes. So a class-based approach has a lot of concepts from the OOPS. We'll be looking on it in the later part. Similarly, we have similar to the dictionary part, we have a lot of functions over here, and the Python class which contains the methods corresponding to different classes. So this day function over here with its attribute as day of week, this is going to replace the match keyword that we saw in the match case, and it helps in validating if there is any match. Say if you have any, say, cases that match or any function that match with the required input. The get attr function that we have here, the get attr, it means nothing but get attribute. It carries 3 parameters over here. One is the object, the name, and we have the default value or the default scenario. So what it does is that this function returns name of attributes present in the object, and it returns the output in return. If there is no say attribute present, it will move to the default value. And this is how it dynamically retrieves and calls method corresponding to the cases. So here's a small example using the match case. So we have our the HTTP response status. Say the popular response status that we have are 200, the 404, the 500, and the default status code. So using this match and case, we are going to check if we have any, say, any block to print with this response status. So now this match will check if 400 is present in any of those cases. I mean, the 404 is present. If it encounters this block, it is going to print not found. Let us see if this code works. So as you can see, my block has been executed. My HTTP code was 404 and the statement that I had was not found. So let us see some more examples using the match case. So in this example, we are having a currency conversion. So I'm going to get my input from user uh, as a float and in the form of Indian rupees, and I'm going to ask which currency they want to convert it to. And I've used the is upper to avoid any confusion in the case. So whatever case the user is going to enter, I'm going to convert it to the uppercase and then only check accordingly. And here I have a dictionary with the keys as the currency and the rates at how much they differ from the Indian rupees. And I have a outer if statement that checks if the user has entered a correct valid option within the target currency conversion, say, keys. And if it is not there, I'm going to say that it is not present, so please choose from either of these three. And inside this, if I have given a match target currency, I'm going to validate if this target currency that user has passed is within these cases. So in my first case, I have the USD over here. To convert, I have a variable called the converted amount, and for the calculation part, I have the user input that I've got from user, and into the exchange rate. Since it is a dictionary, I'm using its key as the target currency that which I've also got from the user. So once I enter this key, this is going to fetch me the value, and the calculation goes on, and I'm going to print the result within the case itself. And this continues until, say, the user enters from the given three choices, and else if it isn't from any of these three, it is going to print that please choose from only these three. Let us see if this code works. So say I give some value and the currency as, even if I'm giving in a lower case, it is going to convert it using the upper function, and then it it just compares with the cases that already exist over here, and now it calculates the converted amount and it finally prints me the value. A simple demonstration of how dictionary mapping works. So here we have, so we are getting it is just basically returning the day. Say if you're going to give 1, it is going to return Monday, 2 Tuesday, 3 Wednesday, 4 Thursday, and so on. So we are getting the input from the user as an integer, and we are requesting them to give it between 1 and 7. And there is an outer if loop that checks if the condition is satisfied, else it is going to print invalid day. And once the condition statement is true, it is going into the dictionary where it has the keys as 1 to 7 and the values as the day, corresponding day, and are say the same get function that we use to retrieve a particular value using a keyword, and the default value is also passed by. So here our day name is going to save our whole output from this particular say get function. So the dictionary name dot get, and then you pass your key, and then you have your default say value that you want to pass. Once this returns an output, so we are going to print using the print statement, and let us see how this is going to go. So enter a day between 1 and 7. Say I give some 8 now. Let us see what comes. So invalid day. So the key is not found in the dictionary, so it returns the invalid day. Say again we are going to run and check this gives a proper output. So I give 2, so it gives Tuesday. Say this structure can also be implemented using the match case as well as the if else as well as the class scenario. So here we have the same problem, but say you have 3 different types. One is the dictionary mapping method, and one is the match case, and one is the if else pattern. So while you can see that this if else look more say not in much maintainable and readable format, while compared to that you have a better representation form in the case match case, and then even more optimal one is going to be our dictionary matching, where the code looks more appropriate than any of these. So all of the 4 methods have its own pros and cons. Like it applies to the particular situation, or it depends on the constraint where you use them. So it is not say fixed rule that you have to use if else when the number of statements is low. You have to use classes when the complexity is more. It just you just use whichever is apt in that scenario.